machines are becoming more intelligent due to the increasing degree of automation and the greater importance of software. As a consequence, machine manufacturers are pushing forward the development of decentralized intelligent machine modules. With its portfolio of software-based solutions, Bosch Rexroth enables an unprecedented level of engineering efficiency and opens up new possibilities for horizontal and vertical data integration.
Hi, I'm Alan Tubbs, and I'm a product manager for Bosch Rexroth in the Electric Drives and Controls division. One of the challenges we have today is figuring out how to make systems on a plant floor talk to one another and to move data to where it needs to be to make use of it. One of the tools that Rexroth has is the Open Core interface. The Open Core interface gives us the possibility of connecting to systems easily and quickly. Today I'm going to talk about some practical examples of how the Open Core interface can be used. So talking about what Open Core engineering can do for you in a big machine shop production floor environment. Usually a large production facility has a team of maintenance people that are monitoring and maintaining many different machines. They'll have many different responsibilities throughout the plant. So they need to know when a machine goes down or when there's a problem on the plant floor. Then having the connection ability to talk directly to a machine from a smart device like a phone. The maintenance technicians can get information directly from the plant floor from wherever they are. The way it would be used is the maintenance person or engineer's off doing his job in some other part of the plant, and he gets a notification from a machine on the plant floor that a problem has either occurred or is about to occur. Say, for instance, a gearbox is vibrating too much, or a motor's getting too hot, or a process is getting out of spec. There can be an immediate response to where a maintenance person gets summoned to the machine to fix a problem that's causing an immediate problem. Or it could be that we see that something's gradually getting worse on a machine or a process, and then at that point the maintenance person can schedule maintenance on the machine or schedule a correction at a time when production isn't being run on the machine. So the person using the app in this instance would be a maintenance person who would have an app on his phone that's been programmed with the Open Core interface to talk directly to the controller on the machine. The Open Core interface puts the information in the language of the app developer so that he can program the app to talk to our machine in a language he already understands and knows. If we start talking about what Open Core engineering can do with tablets, in that case, we're talking about more local control and feedback from a machine. So in this case, a maintenance person would walk up to a machine and receive information about the process or the state of the machine directly onto his tablet. The Open Core interface allows us to connect the tablet directly to the machine controller and the servo drives and motors that are on the machine and pull data directly from those devices. Vibration levels, temperature levels, things that'll help me diagnose the machine right there on site. I can also pull out information like fault log histories and see the history of the machine and any problems that it's had in the recent past. In this situation, the maintenance person receives a notification on his phone that something's wrong with a certain machine, and then he can go to that machine if it's urgent and take out his tablet to help him diagnose the machine there locally and figure out exactly what's wrong and what kind of action is needed to correct the problem. Without this technology, you're relying on some other notification system to get in touch with the maintenance person. Or it might be that he just has to happen to walk by the machine and see that there's a problem. And what all this does together is speed up the response to reacting to problems and errors on the plant floor, and that leads to more production time and less downtime. Another way to use the tablet is in conjunction with other Rexroth software solutions like EnderMotion for handling. The Open Core interface is great for collecting data directly from the plant floor and deciding what to do with it and getting notifications, but it can also be used to actually control the machines on the floor as well. We're programming the tablet using the Open Core interface to talk directly to the MLC control to access motion features that are in the MLC control. So the tablet can be programmed to access PLC variables or function blocks, or even down to the firmware level to access the commands to command motion on servo drives and I/O directly. Another feature of the OpenCore interface is that it can be used in other development environments like LabVIEW. So in this case, a LabVIEW user who's already comfortable programming in LabVIEW can pull in the OpenCore interface libraries and be able to access the motion functionality in the MLC motion controller or in our servo drives directly. This allows him to program in an environment that he's already an expert in. He can access all the motion capabilities and expertise and tools that we have directly in his own programming environment. In the same application, he can also access feedback data from the system if he needs information on torque feedback or I/O. He can pull that information in directly from the control. In this example, the customer is using National Instruments measuring hardware already in his application to test a circuit board on the backside of a gear shift lever. In the process, they need to be able to move the gear shift lever back and forth as a human would actually use it in a car, and then test the feedback on the circuit board connected to it. They already had all the measurement equipment already designed in to do the testing on the circuit board, but they needed the motion component to add in to move the gear shift lever back and forth. So what they did is they integrated a Rexroth L25 MLC controller with 4 or 5 axes of motion to control a Cartesian robot to actually simulate the movement of the control on the gear shift lever. So the OpenCore interface can do machine control as well, but it doesn't stop there. You can actually use it to help you design the machine. Imagine you have a group of engineers that are designing a machine. The mechanical engineer will design the mechanics and individual pieces of the machine and then hand that off to an electrical engineer who adds some wiring and electrical components, and then that's handed off to an application engineer who programs the machine. What the OpenCore interface allows you to do is to tie all those people together through simulation software so that they can work collaboratively to design their individual parts of the machine all at the same time and optimize it for what the machine is supposed to do. Another benefit is that it allows all the engineers to collaborate and optimize the design before you get to the build phase. So previously it required that the mechanical engineer design the machine and then build it and then start programming it. But now, since you can collaborate through simulation software, you can get the machine designed and optimized the way you want it and then move to the build phase of the project. We hope we've gotten you interested in thinking about the OpenCore interface. This is a series of videos that is geared towards finding a solution that fits for you. If you'd like more information on OpenCore engineering, you can go to our website at www.boschrexroth-us.com/OCE.